So let's see an example of a mixing problem. So we'll start with a 120 liter tank that contains 90 grams of salt dissolved in 90 liters of water. Brine with 2 grams per liter flows in at 4 liters per minute, so that's the incoming right here. And the mixture drains at 3 liters per minute, so that's the rate coming out down here. How much salt is in the tank when the tank is full? All right, so classic mixing problem. Let's set the sucker up. So first I'll annotate my diagram with what we have. So the concentration of the incoming, that's going to be 2 grams per liter. The rate of the incoming, that's going to be 4 liters per minute. The rate of the outgoing is going to be at 3, and the concentration of the outgoing is going to be x over v, where x of t is the grams of salt in the tank at time t, and v of t is the volume of solution. Okay, and so we're given some initial data as well. We have that x at time 0 is 90 grams, and we have that the volume at time 0 is 90 liters. Okay, so let's figure out what the volume at time t is first. So the volume at time t, so this is going to be the rate in minus the rate out times t plus the initial volume. And so I got that from just saying, well, in every time interval t, I'm going to have R in come in and R out go out. So the net gain is going to be this difference. And then I'm going to start at some V naught, whatever that is. So in this particular example, the rate in is 4, the rate out is 3, and we start with 90. So V is going to be 90 plus T. All right, so now we're getting somewhere. Okay, so just as the goal for this problem, what we're going to do is, I guess, first figure out when TF is. So this is the time that the tank fills, and so the tank is going to be full when V of TF is equal to 120 because it has a capacity of 120. And we just saw that the formula for the volume is 90 plus T. So that tells you that TF is going to be 30. Okay, so the goal for solving this problem is to find x of t and then evaluate x at time tf, and that will give us the amount of salt in the tank at the time the tank is full. Okay, so let's see. So for our method for solving linear differential equations using an integrating factor, step 1 is to write this as a linear equation in the correct form. So this is going to be R in concentration in minus R out concentration out. So that'll be 4 times 2 minus 3 times x over v. And we can rearrange this to get dx dt plus 3 over 90 plus t, that's our volume, times x is equal to 4 times 2 is 8. So there we go. We can see to get our integrating factor, this is going to be our p and this is going to be our q. So let's go ahead and compute that integrating factor. So we're going to integrate p. So that's 3 over 90 plus t integrated with respect to dt. And that will give us 3 times log of 90 plus t. by some constant that nobody cares about. And then when we exponentiate that, let's see, well, one preliminary step before exponentiating, we'll take this 3 here and we'll move it so that it's up on top, so that when I exponentiate, the exponential just cancels the log, and we have our integrating factor is 90 plus t quantity cubed. Okay, so now I multiply our equation across by this, so I have 90 plus t quantity cubed times dx dt plus 3 times, and then I've got 90 plus t quantity cubed, but then, whoops, I've got one in the denominator as well, so that's just going to be squared times x, and then this is going to equal 8 90 plus t quantity cubed. Okay, so step 4, I rewrite the left side as ddt of my integrating factor mu times my unknown function x, and the right hand side I just copy from the line previously, and then I verify that if I do the derivative on the left hand side, let's see, so applying ddt to the first factor, it's going to bring the 3 down and decrement it to a 2, and that'll give me exactly what we have right here. And then the other one will just have the derivative on the x, and that's exactly what we have right here. So yes, that works. And now it's time to continue on by integrating both sides. So integrating the left gives me 90 plus t quantity cubed x is equal to, and then on the right hand side I've got 8 times the integral of 90 plus t cubed dt. And then in order to integrate that, well, I can just do the power rule. So there's a u substitution, but I guess we can get away without doing it this time because the du is just equal to 1. So I'm going to have 8 over 4 times 90 plus t to the 4th, and then I have this constant that I actually need to worry about. And so my last step is then just to divide the 90 plus t cubed to the other side, and so I have x of t is equal to, see, so then canceling that off, I have 2 times 90 plus t from the first part, and then I've got c over 90, whoops, plus t quantity cubed from the second part. Okay, now I have my formula for x, and so now that I'm done with that, I can go ahead and use the initial conditions to determine what that constant is. So I have that 90 is x at time 0, and so that's 2 times 90 plus t equals 0, plus c over 90 plus 0 quantity cubed. And then solving for that, I see that c is the 4th power of negative 90, or rather minus 90 to the 4th power. So then I know that my particular solution is going to be 2 times 90 plus t minus 90 to the 4th all over 90 plus t quantity cubed. And then the final thing is to evaluate this at time 30. So I do x at 30, and this is going to be 2 times 120 minus 90 to the 4th over 120 cubed, and then banging that out on the calculator is going to get me 240 minus something that looks like about 37.97, and so I end up with 202 grams of salt.